Okay, guys, we're going to finish off chapter 4 now. I always keep 4.6 separate from the rest of the chapter because you needed to learn how to do integration, um, all the other methods before you learn this one because this one's a little bit more complicated. So far, you've learned to do a power rule. You've learned to do an exponential. You've learned to do a logarithm. And you've learned to undo a chain rule derivative by doing the integration by substitution. But even when you had a substitution, that's what the u was, right? You were still doing just these three. All right, now we're going to learn to undo a product rule or quotient rule. And this method is called integration by parts. And we're going to go back and look at the product rule itself first. When you have the product of u times v, and you take the u and v are both functions of the variable, we'll say x. When you take the derivative of a product, remember the product rule is everybody gets a turn, but you have to go one at a time. So I can copy the first and take the derivative of the second, plus, because it's a product, copy the second and take the derivative of the first. We see how in this case the first waits on the ladder while the second goes down the curly slide. Remember the curly slide rule. In this one, it's the other way around. So remembering a product rule derivative, if we take this equation right here and we integrate both sides of that equation, integrating addition means we're going to integrate each bit, right? Well, remember the integral of the derivative is just the thing that you took the derivative of, right? So in this method, what we're going to be integrating is only one part of the product rule derivative, right? So if I take this piece and isolate it, I'm going to subtract this piece from both sides. And when I integrate the derivative, I get just that product left. So when I'm integrating u times the derivative of v, I'm always going to get u, the same thing that I have right here, times v, which is whatever the integral of this is. It's a little complicated, but once you get, if you practice it, you'll get it. It's not a big deal. So I have to find what v is, having identified the derivative of it. All right, minus the integral, I copy the v again, and then I've had to take the derivative of whatever I chose to be my u. So we're going to start with an integrand that is a product of two functions. One of those functions is u, not you personally, and the other function is the derivative of some function v. We're going to do some preliminary work, and then all we have to do is plug stuff into the formula. And when we get this last integral that has to be done, this is going to be simplified compared to what we started with. And it's very cool how it works. So every night as you lay your head on the pillow, I want you to say to yourself, uv minus the integral of v du, uv minus the integral of v du, uv minus the integral of v du. Got it? Okay, we have to do integration by parts anytime we have an algebraic term times an exponential term when the algebraic term is not the derivative of the power. If you see this, and from what we learned with substitution, there's a single e, so we would set the power equal to the u, but the derivative of u is dx in this case. And you see we've got too much stuff. So anytime there's too much stuff, you always try substitution first. But if you've got an extra function of x, you got to change gears and try integration by parts. Okay, so I'm just going to give you a quick little rule here. E to the u is the last choice. For you guys, it's never going to be you, not you personally, the last choice for your u, okay? and I'll tell you how to pick the u as we move through this. So in this problem, we have 3x and we have an e to the x. The e to the x is never u. So we're going to choose 3x to be the u. I'm going to put it in my little cheater box here. If the 3x is u, cover that up and you see e to the x dx, that's what's left in the problem. So that is, by default, your derivative of v. So to fill out the formula, we have to take the derivative of the thing that we chose to be u, and the derivative of 3x is just 3. Don't forget the dx, okay? When we have the dv as the rest of the stuff, we have to integrate this guy to get the v. So the integral of e to the x dx is just e to the x. And then we're ready to plug stuff into the formula. And the formula we'll use is uv minus the integral of v du. So you see that we have the 3x, that's my u. V is e to the x, there's my v, minus the integral of v is e to the x, du is 3 dx. Now for this integral, I still have to do this integral, but it's going to be much simpler than what I started with. And 90% of the time, once I simplify this, it's going to be the same thing I did up here in the cheater box. That's one way to know that you're on the right track, okay? So in this case, all I have is a constant times e to the x dx. So I'm going to just throw that 3 out front. And then the integral of e to the x dx is just e to the x. This first thing is done. He's never going to change. You're just going to copy it and then do this last integral, and you're done. You can leave this answer like this, or you can factor out the common factors, the 3e to the x, and write it that way. One thing that I highly recommend that you do for every single problem until you get really good at this is to take the derivative of your answer and see how stuff gets subtracted away and you end up with just the bit that you were taking the integral of. So if you take the derivative of this right here, you have a product rule here plus another. And in that product rule, remember, there's two parts added together. One of those parts is going to get subtracted away, and you're going to be left with the original. Now, it's an easier derivative if you factored it, because now it's this times this, and it's just a product rule and you're done. But you'll see how stuff simplifies. Okay, example number 2. When we look at this integrand, both of these pieces, the top guy and the bottom guy, are algebraic. Normally, with substitution, we would set the underneath the radical equal to u, but the derivative of this is just dx, and you see that we've got too much stuff. So we have to change gears, and we kind of have to think of this or look at this as being the integral of a blob times another blob, and that guy in the bottom is x plus 1 to the minus 1/2. So remember, when you're doing integration by parts, you're looking for two factors, two parts. And in this case, you always want the u, I'll say it again, you always want u to be the part that is going to get simple when you take its derivative. When I take the derivative of blob to the fractional exponent, positive or negative, he's never going to get simple. But this guy right here, plain old x plus 2, his derivative is just dx. So the x plus 2 is the obvious choice for the u. And that means the rest of this stuff is dv. So in my cheater box over here, I've picked the easy piece to be the u, and the rest of it is dv. All you have to do is make sure that you can integrate that, because to find the v, you've got to take the integral. Okay? Now, when I do that, the inside is u, and I have an exponent. It's just a power rule. And the derivative of the inside is right there. It's perfect. It's ready to go. Sometimes you have to do a full-on substitution integral to get the v, but you know how to do that now. You've taken a test on it already. If that was a 2x inside there, I would need a 2, right? And that would give me a 1/2 out here. So sometimes even in your cheater box, you're going to have to do the substitution stuff like in the margin of your paper to get your v. So this problem, the simple part is u. I take its derivative, I get plain old dx. The rest of it is dv. I have to integrate that. And this is just u to the minus 1/2 du. So I copy the u, I add 1 to the power, which makes it positive 1/2, and I divide by the new power, and I simplify that. Fraction in the bottom inverts and multiplies, gives me 2 on the top. Blob to the 1/2, I have to see that as the square root of x once I write my final answer. So plugging stuff into the formula, uv minus the integral of v du. So the u was the x plus 2, the v was 2 square roots. This piece is done. I'm just going to write them in an order that looks nice. Minus the integral, copy v, copy du. That 2 can pop out front, and I see that square root over here as blob to the 1/2. This is the last integral that I have to do, and it's almost the exact same thing that I did up here. The only difference is the power. I have u on the inside to the power with perfect du on the outside. So I'm going to add 1 to the power and get 3/2, divide by the 3/2. The 3/2 is going to flip and multiply. So I'm going to get 2 times 2 is 4 in the top, and that 3 stays in the bottom. And here's my final answer. Takes practice, but take it step by step, simplify as you go, and it's not so bad. Okay, something that we need to really think about is the fact that we know the derivative of the ln of something, but we have never ever discovered what the ln is the derivative of. We've never gone backwards. So the reason that we haven't gone backwards is because even just to take the integral of the ln of x dx, you have to use parts. Now ask yourself, well, what are my parts here? I have to have 2 different parts. Well, the only 2 parts are the ln of x and the dx. And I've been saying all along, don't forget your dx. He's really, really important. And this is why. Because in this problem, he's one of the parts. Okay? Now, something I want to point out. Don't ever, ever, ever separate the letters ln from what you're taking the ln of. This is the ln piece right here. That's an operator. That's like writing a plus. It has no meaning at all unless it's operating on some values. Okay? So ln alone makes no sense. It always has to be the ln of something. So this is not multiplication. Please, please, please keep that in mind. So the ln of x is a part all by himself. That leaves dx to be a part by itself. Now, the biggest rule that you have to remember is the ln is always the u. Okay? Don't ever forget that. If there's an ln in your problem, you have to set him equal to u. All right? Don't forget that. So here we go. I've got this part and I've got this part. I know that ln has to be u. I take his derivative. I get 1 over x dx. It is what it is. That means the rest of the stuff, this dx, is my dv. And when I take the integral of dx, I get plain old x. All right? Now, we're plugging this stuff in. Here's u. here's v, minus the integral of v du. Once you get the stuff in your cheater box, you're just plugging it into the formula, uv minus the integral of v du. Now, never, ever move on until you have simplified what you have, and you see that you have an x, this is x over 1, times a 1 over x. Well, you've got an x in the top and an x in the bottom. They're going to cancel, and you're going to be left with plain old dx. And look at that. It's the same thing that we already did. 90% of the time, your final simplified integral has already been done in your cheater box. Okay? And if it's not the exact same thing, it will definitely be almost the same exact thing. So, here's what we have. We've got the u times the v. That's just x times the ln of x. I just wrote this x in the front so that we know exactly what we're taking the ln of here. Minus the integral of just the dx, which gives me just an x here. And so this is your answer right here. When you take the derivative of this answer to check it, you'll see exactly how things worked out. And you see below that, I just factored out the x to make it look pretty. All right, let's mix it up a little. Now in the next problem, we have these two parts. We have an x times an ln of x. And remember the rule, the ln is always the u. That leaves x dx to be the dv. So derivative of the ln of x is 1 over x dx. Integral of x is x squared over 2. Just add 1 to the power, divide by the power. And now we plug that stuff in, and we've got u times v minus the integral of v times du. And you have to simplify. So we've got a 2 on the bottom that can come outside, x squared on top, x on the bottom. One of those x's will cancel, and we're going to be left with just an x on the top. And notice that this integral is the same that you already did. All you have to do is add 1 to the power, divide by the power. So this stuff in the front, I just made it look pretty. Simplify your integral, and now you can integrate. So you're copying the first bit. He never changes. And then in the second, the integral part, I'm going to copy my minus, I'm going to copy the half that was sticking out front, and then I'm going to integrate, add 1 to the power, divide by the power, and then I simplify the second piece. So it's negative, it's x squared on top, and it's 4 on the bottom. And here's your answer, and this is perfectly fine. If you want to get a common denominator, you can factor out the common x squareds and factor out your common denominator, and you end up with your answer in this form. And that's perfectly fine, or you can leave it in the original form.